Hello everybody. I wanted to take a moment and actually get a recorded video on the notes we just had over ATP, enzymes, and catalysts. I had a lot of students who have come up to me and said, I missed those notes and I got them, but I don't understand them. And so I figured I'd create this video to kind of help you understand them a little bit, understand the notes anyway. I'm going to skip these first couple of slides, which explain why we eat. Essentially, we eat because we need food. And, well, we need food, we eat food because we need the nutrients the food possesses. We need the proteins, we need the lipids, we need the carbs, and we need the nucleic acids so that we can break them down and absorb them into our bodies and turn them into us. We also get a lot of energy from the carbohydrates and the lipids, so, good stuff. So digestion is the process that makes that happen, so I want to start right here and say, okay, digestion, yay. It breaks down food into its basic components. It requires physical energy. That's when you chew on it. Acids and biles in your stomach and intestines will finish it, and then you will evacuate through your bowels anything that the body can't really use. And so all of the energy in your body gets stored inside in some form, and it exists as a form of energy known as ATP. That's the stuff we want to talk about today. It's found inside your muscles and all kinds of things. ATP, the T stands for tri. In this case, there are 3 phosphates here, and so it is a triphosphate. This is the currency of life right here. This is the stuff that allows you to flex your muscles, to walk, to move, to do a lot of the stuff in the body. You need that ATP, okay? And so when you use ATP up, this is the reaction that happens, okay? We drink some water, the water gets into our bodies. Well, we talked earlier about condensation reactions. Well, here's one that happens. Water actually is lysed here. It's broken apart, and when it's broken apart, it snaps one of these phosphates off, and you end up with ADP, D meaning di, plus an extra phosphate. Now, weightlifters and athletes will actually take a supplement called creatine phosphate, and that's because creatine can bind onto this phosphate here and reattach it to the ATP here. There's a different process that does that, and that's a little more than you need to know. But creatine phosphate adds extra phosphates here, and so it allows athletes, bodybuilders, things like that to have more get extra energy quicker there, I guess would be the point. But in this case, all we really need to know is that we start off with ATP. And in order to get the energy that's stored in this molecule, we have to break this last phosphate off. And when it breaks off, it releases energy, and there's the byproducts there. And so moving on, a substrate is a molecule that an enzyme acts on. The molecule, the substrate, it comes from the food you eat, and so just to be simple, I say that substrate is the foods you eat. And at this point, it's been broken down a lot, and we can't really use this molecule right here. It doesn't fit into what we need, and so an enzyme comes along and binds to this guy right here. And when he binds, he breaks him apart into his products here, and we can actually use each one of these guys. And so we need to take this substrate and get it broken down. If you look at the bottom here, it's 1 second, 1.001 seconds, and then 1.002 seconds is all it takes to break that substrate apart. And you'll notice that the enzyme hasn't been changed at all. It stays the same shape, so the enzyme is not affected by this reaction. We can use this, we can't really use this until it's broken down. Now, if you're missing the enzyme that breaks this substrate down, you will not be able to get this guy into his products here, which means you can't use this. All right, a lot of people who are lactose intolerant are missing the enzyme to break down lactose and to use it in a way that we could do it, and this guy just tears a new one going through your intestines there. All right, so enzymes, we've talked about this before. Enzymes are proteins. and they act as a catalyst to help a complex reaction occur. A catalyst, you'll learn on the next page here, is anything that increases a reaction. But for now, basically the same process. You have an enzyme, and this is the active site where that substrate's going to bind, and the enzyme breaks it apart into its products, and we can use these products. This guy might go to your liver, this guy might go to your DNA, you don't know. It just depends on what the product is and where it can be used. And so finally, a catalyst increases the rate of a reaction without undergoing any permanent change itself. If we go back here, an enzyme is a catalyst. He bound to this guy, he broke it apart, and the enzyme itself was not changed. So a catalyst increases the rate of a reaction. This is what would happen, how much energy and time is needed in order for a chemical reaction to happen without the enzyme. By adding the enzyme to do some of that work for us, the amount of energy changes. And so we don't have to use as much energy in order to either combine, or in this case wants to combine them or break them apart. Whichever you're doing with that enzyme, it requires energy, and the energy with the enzyme is always less in this case than it would be without it. All right, and so you have just this amount of time, amount of energy. Catalysts make it happen a whole lot more efficiently than without it. All right, and so if you get a chance, watch this video. Efficiently converting fat into energy is kind of fun. Interesting little video here. This guy who likes to swim the channel. All right, that's all I really wanted to say. Just a real basic, very basic covering over ATP and ADP and substrates and enzymes. As always, if you have any questions, go ahead and contact me, and I will help as best I can. Thank you.